Hello all, welcome to Code Hub. Today let us solve the LeetCode daily challenge validate binary search tree. Given the root of the binary tree, determine if it is a valid binary search tree BST. A valid BST is defined as follows. The left subtree of a node contains only nodes with keys less than the node's key, and the right subtree of a node contains only nodes with keys greater than node's keys. So both the left and right subtrees must also be a binary search trees. So how can we solve this binary search tree? How to validate the binary search tree? Obviously, we know one technique that if we traverse a if we traverse a tree in order fashion, if it is going to be a binary search tree, then the in order traversal will give me a sorted order of nodes. So what we will do is we will store the in order traversal of the binary tree, and whether we will check whether the vector is in sorted order. If it is in sorted order, then the tree is a binary search tree, valid binary search tree. But here the time complexity here is order of n, and the space complexity is also order of n. So how can we optimize this space? That is, we don't want without using an extra space, extra vector. How can we do this problem? That is the main optimization that we are going to do here. That is, consider if we are having some for each and every node, we should check whether this one is if this one is going to be lesser than this root. If it is going to be a left subtree, if it is going to be a right subtree, this 3 should be greater than 2. That is if we are having some left boundary, we have to check whether this 3 is greater than this left boundary. If there is some right boundary, we can check whether this node value is lesser than that right boundary. If this is the case, then we can say this is a valid node. Else we cannot say this is the valid node, and we cannot place that node into that position. So this is the thought process that we are going to use here. So for any given node, if we are able to give the minimum and the maximum boundary to that particular node, and if that node is inside that boundary, then we can say that that node is at correct position, and this is going to be a valid node in that position. If this is going to be true for all the subtrees in our given tree, then this is going to be a valid binary search tree. If that node is not going to be inside the boundary, then there is a conflict occurs. So we will say that it is not a valid BST. Consider we are having a root. Consider we are having a root this 2. So for this root, we don't know what is the left boundary and what is the right boundary. So initially we can have our left boundary to be the minimum value int min, and the right boundary which is the maximum value int max. So we have to check, we are going to check that current node's value, which is 2, is inside the boundary. 2 is greater than or equal to int min, and it is less than or equal to int max. So this is true. So we are going to its left and going to check the same condition. While going to its left, what is our int min, what is our left and right boundary? While going to our left, this one, we know that this one should be lesser than this 2, and it should be greater than this int min. If it is not, then we have to return false. So what I am coming to say is, whenever we are doing a left recursive call, this current node's value becomes the right boundary for the next recursive call. Similarly, for this right recursive call, the current node's value becomes the left boundary, which is left boundary for this next right recursive call. That is, for this current node 3, we have to check whether this 3 is lesser than the right boundary, which is int max, and greater than the 2. which is the left boundary. It is not necessary it should be int min, because this 2 is the current node and this particular node should be greater than this 2. It should not be int max, right? So our left boundary becomes 2 now. So for our left recursive call, we have to pass the right boundary as the current node, and for the right recursive call, we have to pass the left boundary as our current node. So what we can say is, we can just return the function that we are going to define. We are going to define check valid BST, and we are going to pass the root, and we are going to pass the left boundary and the right boundary, int min as well as int max. So this is our function, and we can define the function. This is a private function. This is a boolean function which is going to return that boolean value. Check valid BST and tree node star root int left boundary and int right boundary. So we have defined this cases. So whenever we are having a root as or null, we can say we can just return true. So this is not going to conflict anything. Then we can get our left subtree's value. Check valid BST root of left. For our left subtree, the current node becomes our right boundary. So left boundary stays the same, and root of val is the right boundary for it. And similarly bool right. Check valid BST root of right. While we are passing the root of right, our current node becomes the left boundary for the next recursive call, right subtree. So root of val becomes the left boundary, and the right boundary stays the same. And we are having a left as well as a right. So we have to return left should be equal to true and right should be equal to true, as well as our root of val should be greater than my left boundary, as well as my root of val should be lesser than my right boundary. That is nothing but my root of val is staying inside the boundaries. If this is the case, then we are going to return true, else we will be returning false. So let us run our code now and check whether it is getting the expected output. And sorry, we should insert a comma here, and let us run our code now. Okay, it got accepted. Let us use the example test cases as well. Okay, we are getting the expected output true and false. Let us submit our code. So the time complexity here will be order of n, and the space complexity will be order of 1, since we are not using any extra space. Let us see what is the condition here, whether it is failing. Okay, here this value itself int min value, so it is going to be lesser than or greater than or equal to, and lesser than or equal to. If that root of val is inside the boundary, then we can say return true. Yeah, sorry. 1 minute. Why it is false, getting false here? Yeah, to be a valid binary search tree, obviously this greater than should not be equal and should not be equal. So we have to keep it as greater than left boundary and lesser than the right boundary. So 2 comma 2 comma 2. So for this then this case will be passed, but this case will be failing. So what we are want to do is, we are having an input where we are passed the int max value itself. So instead of having an int min and int max, let us have the long min and long max. So this makes sense because we'll be having the long min and long max value, so that that is not going to be equal to this left boundary or right boundary. So this we can just typecast to long. Now it will definitely get accepted and there will be no errors. It should not be. Yeah, it got accepted. So now let us submit our code. But that logic is the logic is the same what I have explained. So hope you like this video. Let me know in the comments. Let us see in tomorrow's daily LeetCode daily challenge. Until then, bye. Happy LeetCoding.